Okay, so we're doing lesson 26, solving multi-step equations. So just continuing off of what we've been doing the last 3 lessons, so it should come second nature. As a reminder, when you solve multiple step equations, you end up doing PEMDAS backwards. But let's write this down, P-E-M-D-A-S. Parentheses or grouping symbols, exponents, multiplication, division, addition, and subtraction. Now we need to add right here, simplify at the bottom. So when we're doing our order of operations, we do it backwards. First, you want to simplify it, which just means basically to combine like terms and stuff like that. Okay? So that's basically what simplify means. It means combine what you can combine and make it in its simplest form so you don't end up doing extra steps that you don't have to do. So you're looking for addition and subtraction to move, then you're looking for multiplication and division, then you'll do the exponents. Okay, just as a reminder on exponents, if you have an x squared, the inverse of x squared is the square root. So in order to undo a squared, you would square root it. Okay? All right, so let's start with examples. Example 1. It gives us this problem, 5x plus 8 minus 3x plus 2 equals 20. Okay, so I want to identify my like terms. Now most of you are good at identifying like terms, however you're not good at combining them. So make sure that when you identify your like term, you include its symbol. If it's positive, there probably won't be a symbol. But if it's negative, make sure that that negative is included when you're boxing it or circling it or whatever it is that you do. Okay, and then I have an 8 and I have a 2. Okay, so I'm looking at each side of the equal sign. I'm looking at each side of the equal sign. If I do not have an equal sign, I will not have an answer. I will just have a simplified expression. Okay, so I'm going to start combining like terms. I want my variables up front, so I'm going to combine a 5 and a negative 3. That's different sign difference, and 5 is farther away from 0, so it'll be positive. I get a positive 2x. Next, I'm going to combine my 8 and 2. They're both the same sign, so I'm adding those same signs. Sum. I get 10 equals 20. Now I'm only combining like terms on this side of the equal sign because there's nothing to combine on the right side. But if there were something to combine, I would only do it to the right side and then simplify after. Okay, following that step, we just go to what we've been doing in lesson 25. We just start to look at our order of operations. We just simplified. I'm looking for addition and subtraction. I see my addition. So the inverse of addition is subtraction. So I'm going to subtract 10 from both sides. Now I'm left with 2x right here. That just drags right down. Don't forget your equal sign. And 20 minus 10 is 10. What is the inverse of 2 multiplied by x? Divide by. So I divide on each side. That will simplify out to x. Reminder, we're not just canceling these. 2 divided by 2 is 1, and 1 times x is x. So that's where that comes from. 10 divided by 2 is 5. Okay, so that should be my final answer for this. If I want to check it, I just plug it back in. So 5 times 5 here would be 25 plus 8, and then minus 3 times 5, which is 15, and plus 2. And then I would just check that really quickly. 25, and you can type this in your calculator, obviously. 25 plus 8 is 33. 33 minus 15 is 18, and 18 plus 2 will make 20. So it does check out and it works. Okay, on this next example, I really want you to ask questions as I go through here. So if you get confused at all, you need to make sure to ask me right on the spot, not after you get horribly lost in the weeds. Okay, so here's the problem. X plus 3, open parentheses, 2x plus 4, close parenthesis, equals 47. Again, I have nothing over here on the right side of my equal sign. Okay, I have nothing there. Reminder, because I've seen this mistake on y'all's test, when I say what you do to one side, you must do to the other, I'm talking sides of the equal sign. If you don't have an equal sign, then you can't do it to both sides because there's only one side. Okay? So following this, in order to simplify, to do my simplification, like I said to do in my backwards order of operations, I would need to get rid of this 3, distribute it out. I would want to get rid of the parentheses in essence. But in order to simplify this, I'd have to move that 3. So I'm going to just drag down my x. I'm going to add and then I'm going to start distributing. So 3 times 2x, and a lot of y'all guys just drop the x off of this. If I have 3 times as many 2x's, I have 6x's. And then I need to go to the next step, dropping down my sign again, which is addition, my operator. 3 times 4 is 12, equals 47. Okay. Now I have a problem that I need to combine some like terms. I have x's, same last name, so I can combine those, and I have nothing else that goes with that 12, so I'm just going to leave it alone. Combining those, I have a 1x and a 6x will give me 7x's plus 12 equals 47. Now I can start solving like we've been doing. So inverse operation of add is subtract 12 then from both sides. Dropping down my 7x, I have 7x, that goes away, and it equals, looks like 35. Inverse operation of multiplication, division, good, and x then equals 5. Well, that's a coincidence. Then, again, if I want to check, I just plug right on back in and double check and verify my answer. Okay? Highly suggest doing that on your tests as well as your homework, especially since you have calculators. Okay, any questions? No one asked me anything. All right. Choose your poison. All right, example 3 is where I see most mistakes. I see a lot of people forget to distribute a negative or lose a negative, and that'll be consistent throughout your career in algebra and in geometry. So here's the problem. 5x minus, open parenthesis, x minus 3, close parenthesis, minus 1 equals 18. Now this is where most people get confused. They don't realize that this is not just an operator, this is a negative 1. Right? This is a negative 1 that needs to be distributed out into your parentheses. So that's our simplification process. I need to distribute my negative 1. So I'm going to take that negative 1 and I'm going to distribute it to the x. So dragging down, just my 5x just drags down. I have a negative 1 times x, which gives me a negative x. And then I give my negative 1 to the negative 3. Now this was another common mistake I've seen with you guys. Same sign, sum. So I need to write down plus. Okay, so 1 times 3 is 3. And then dragging down my minus 1 at the end, and my 18. Any questions thus far? Right. Combine like terms then. I have a 5x, and I have a negative x, negative 1x, and I have a 3 and a negative 1. So it was nice that they're already right next to each other. So 5x minus x, those are different signs. So 5x minus x leaves me with just 4x's. That's the same as 5 minus 1. Okay, do not forget your last name there. Then we have 3 minus 1, which is just 2, positive 2, so I'm going to put the plus there, and I'm just dragging down the 18. And we're back to what we normally see. And then we start solving like we normally would. So inverse of plus 2 is minus 2, so I'm going to subtract 2 on both sides. I'm left with 4x, and on this side I'm left with 16. Divide by 4 on both sides. X then has to be 4. And when I plug into this to check it, I'm going to show you guys again what this would look like. It's 5 multiplied by 4 minus, in parentheses, 4 minus 3, close, minus 1, should equal 18. That's our question. Okay, so 5 times 4 gives us 20. And then I'm going to do inside of my parentheses right here, 4 minus 3 is 1. So it's minus 1, minus 1. This should be 18. So 20 minus 1 is 19. 19 minus 1 is 18. That checks out, and it works out good. Okay, always plug it back into your original so that you don't accidentally mess up. Still no questions? Last example then. Example 4. Application in landscaping. It gives us this nice pretty little drawing of a right triangle indicated by that symbol right there. So it has a 2x in the upper left hand and an x in the bottom right hand. Now by the triangle angle sum theorem, what do we know about the interior angles of a triangle? What are they always equal to? 180. So in here, all of those angles will equal 180 degrees, right? So keeping that in mind as we read this problem. Jim is building a right triangular flower bed. One of the acute angles will measure twice the angle of the other acute angle. So he gives them labels x. What are the measures of the two acute angles? So since we know this is a 90 degree, we know we have 90 degrees, and then we have our two other angles. We have 2x, and we have x. And what do we know will happen when we add all three angles of this triangle? They will be equal to 180, right? And now I can just solve this problem. So I set this inside of my squares, and I leave my 90 alone because there's only one over there. So combine these like terms. I have 3x, and I'll just drop my 90 down, equals 180. I want to get rid of my addition, so I have to subtract 90. Now this is another problem I see a lot of times with you guys. You try to subtract 3x. That doesn't do you any good because we want 3x by itself. So we need to get to isolate the variable, we have to get 3x by itself. So our 90s go away, 3x is left, just drops down. 180 minus 90 is 90. Inverse of multiply by 3 is divide by 3. And I'm left with x equaling 30. Now to answer the question, I have to make sure to find the measure of the two acute angles. So the first angle will measure 30. So the measure of angle, I'll just call it x, will equal 30 degrees. And then the measure of angle 2 times x will give me 60 degrees. And there's my two answers right there. So the measure of the two acute angles are 30, 60s. And these are a really common triangle. They're called a 30, 60, 90 for obvious reasons. That's their angle measure. And we'll learn more about them in geometry. Any questions? All good to go then.